In Module 4, we're going to focus on the MX as a gateway. So we will actually, Module 4 and 5, we heavily focus on the routing capabilities of the MX. So we will start first with basic functionalities with the MX. We'll go through the MX routing decisions, like the order of operation, which kind of like routes will take precedence over other routes and why. And then we'll go through the site-to-site VPN concept and how we can enable it. We'll have some sort of scenarios to go through when we have the MPLS connected to the LAN versus connected to the WAN and how to configure both. And then we'll try to cover a little bit about the hybrid network best practices. And the end, we will talk about the quality of service and traffic shaping and how to utilize it with the MX and how actually it works. So let's start talk about the MX routing decisions, like how the MX actually make their routing decisions here. So anything they're going to be directly connected to the MX, of course, will take the highest priority. So when you configure a VLAN, when you configure multiple VLANs, then basically these are considered as connected or directly connected. The second will be the client VPN. So if I terminate a client VPN and I have this subnet in the routing table, that would take precedence over if I have this subnet actually coming from a site-to-site VPN or even from a static route. And then we will talk about static routes. So the third option for the MX will be static routes. So when the MX actually look into the routing table, it makes the decision like this. We'll first see, do I have any, this destination IP, is it part of the directly connected IPs? If yes, it will get it routed through straight away. If not, it will look into the client VPN routes. Is it actually the client VPN route? Yes, okay, push it through. No, then go to the next, which will be static routes. So if you configure any static routes for this subnet, then we will follow this kind of like static route. If not, it will check into the auto VPN or site-to-site VPN routes. So when we establish site-to-site VPN, we advertise the local subnets, and we will go through this in details. And then basically these local subnets will be installed in the routing table, but it will be treated as a not a high priority in terms of the order of operation. It will be taking rank number 4. And then if this route still doesn't exist in any of the above kind of like tables, then it will look into the non-Meraki VPN peers. So if I established a peer or site-to-site VPN with another vendor or even another Meraki device that part of a different network, we will look into the subnets that get advertised and see if the subnet actually part of the list or not. If we fail to find this IP, this traffic will get netted and pushed out to the WAN interface. And this is how it works. So if I actually look into traditional router and a Meraki MX, maybe in the traditional router, you will find that you can have multiple routing protocols. You have a different administrative distance, and that will dictate which route will take precedence over the other. For us, this is the order of operation, so we'll look into directly connected and then client VPN, and then static routes, site-to-site VPN, non-Meraki VPN peer. If all failed, then we will net the traffic and push it over to the WAN interface. So as you can see, we don't have a default gateway concept here. It's basically netting the traffic and push it over. So it's kind of like we have a built-in default route established pointing to the WAN. Whenever we actually fail to locate a subnet, we go to the last option, which basically netting that traffic and send it over to the uplink device. So this is the order of operation. This is how the MX make the routing decisions. So for example, if I have a site-to-site VPN established between two sites, maybe over the WAN, and I want the traffic to go actually through the LAN to the same subnet, so what I can do a static route pointing this traffic to the LAN interface, which will basically take precedence over the site-to-site VPN route. And whenever there's a failure in this LAN interface, then the site-to-site VPN route will be there and it will take over. And that's where we actually use the MPLS to be connected to the LAN and fail over to the WAN in case I want to do some sort of non-netting kind of like traffic push over my MPLS. And we'll go through this in details, but this is like a really important to everyone to understand how the MX can make the routing decisions. And basically when we understand this, we will be able to play with the MX the way we want, how to influence the traffic to go the way we want. All right. Now, before we're going into the details of how to configure things and how these things actually look in real life, I want to kind of like pause here and talk a little bit about the DMVPN and how we changed DMVPN to any VPN or site-to-site VPN from a Meraki side and how we actually simplified it. So if I look into the traditional DMVPN, of course we need to have routers or endpoints to be able to kind of like establish tunnels. And these devices will need to be connected to the WAN or to the internet. But because these sites cannot talk to each other yet, because they don't know each other, if I want to do peer-to-peer kind of like traffic, then I will establish secure tunnel from each side to the other. But that's actually not an easy job to do, especially when you have a big scale. So DMVPN comes into the game by basically having some sort of like hubs that can control that. But before we actually start to push traffic between sites, we need some sort of a security layer here to make sure that the traffic that we push over internet is securely encrypted. So what we do normally, we get like a certificate authority, which is another router. And basically this certificate authority will release certificates to the routers that I have in my network. And that basically is just kind of like having an identity to every router. And whenever I talk to these routers, I will use this certificate to encrypt traffic. But the other thing that we all need here is a VPN registry. So the VPN registry is basically talking to all these sites, knowing their IP addressing, understanding, where they are, what IP addresses they have, and all these details. And basically push this routing table to all the routers that we have in the network. So whenever they want to talk to each other, they know which IP to reach out to. But, on top of the certificate authority that we talked about, we need to have public IPs on these routers to be able to establish the tunnels. Of course, you can use private IPs, get netted somewhere, but at the end you will open yourself up because the remote sites will need to have like an open IPs to accept any IP basically trying to establish tunnel, and we will just rely on the certificates to make sure these users are actually part of my network and not someone that trying to hack my network. So public IPs will help you out to lock down the subnets that you can talk to, and of course it's more secured, but also it comes with cost. And then we talked about the VPN registry, that we must have a VPN registry that can hold all the IPs and the details. But on top of all that, you will need to have dynamic routing, because we talked about how these sites can establish tunnels between each other, but we didn't talk about how these sites will share their LAN subnets between each other. So you need to have some sort of dynamic routing like EIGRP or OSPF or BGP, whatever you like. And then we talked about we must have an edge devices as well as hubs in the network so they can actually have a topology created. So that's the traditional DMVPN. And let's see how we actually change this from the traditional DMVPN to Meraki. So let's now say I'm actually going to use Meraki MXs in my remote sites. So first of all, these Meraki MXs, they come with certificates built in. So we actually use public certificate on each of these devices to be able to talk to our cloud. So they actually have a certificate built in, and it's a public certificate, not private certificate. So public certificate is more expensive, while private certificate is less expensive, and also it's not as secured. So we don't need certificate authority anymore. That's actually the dashboard. So the dashboard can verify the identity of these MXs and basically can let the other MXs know the identity of the other ones. And then the VPN registry, we actually don't need it because all these MXs, they already established tunnels with my dashboard. So the dashboard knows the details of every MX I have. And the good thing about this, that the MX is the one that reaching out to the cloud. So it's actually proactively trying to look for the cloud and send the details of this MX. So whenever you actually have an MX that have dynamic IP addressing, it will basically every time change the IP because it goes offline or something. It will reach out to the cloud every time that happens and tell the cloud the new IP address of the MX. So the cloud does have the latest details of these MXs and their IP addressing and so on. So actually the dashboard is acting as your VPN registry. It actually have all the public and private IP addressing of your MXs. So you don't need to have a VPN registry. So the way we look into this, we actually get rid of the certificate authority. We don't need certificate authority anymore. Actually, it's not really required to have a public IPs, because even if you have private IPs get netted somewhere, or you have a dynamic public IPs being given to your site, we will update our VPN registry accordingly with the new IP addressing and get every MX in your network or in your organization with the new list of IPs. So whether you have private IPs, public IPs, dynamic, static, doesn't really matter. We'll be able to get this information always up to date to all the MXs. VPN registry, that's already our dashboard, so you don't actually have any device for it. And then we actually trying to simplify things, so we will be able to advertise the subnets through the site-to-site VPN without using dynamic routing. So you find yourself that when you want to establish site-to-site VPN with a Meraki network, you only need to have edge devices and hubs, and that's pretty much it. And even if you don't want a hub, you can actually have all edge devices talking to each other, and that's it. So this is how we simplify things with Cisco Meraki. So we don't actually need much complication here to establish the site-to-site VPN. So I guess I want to take this chance now and start to work on our topology to see how we can establish this and how we can test the traffic to check where the traffic is going. So what I want to do in this topology, I want to enable site-to-site VPN between my sites. So I have one site here connected through internet, and this is in path-through if you still remember. I do have two sites here connected to both, actually these two, connected to MPLS and internet. So Juventus and Manchester United, they both have two links. One is to MPLS and one to internet. And they have Arsenal, which is only connected to the MPLS. So what I want to do, I want to make sure I have full connectivity across all my sites. So I want to, from Milan, be able to talk to Arsenal through my internet link, and I want to have Juventus to talk to the rest of the network through my MPLS. Whenever that fails, I want to go to the internet. So I want to have full redundancy. So let's build this up. It's pretty easy to configure with Cisco Meraki. All what I need to do is I need to go to site-to-site VPN here and basically enable the feature. So I can go here and say I want to set this up in a hub mode, or I want to set it in a spoke mode. So the difference here between the hub and the spoke, that with hub or full mesh, you make every MX in your network as a hub, so they can establish tunnel between each other when they want to talk to each other. Or you can put it in a spoke mode where you can select a hub in your network and say, this is my gateway to talk to other sites. So let's simplify things and make it only in a hub mode, so full mesh. Here it asks me which subnets I want to advertise through. So it will list down all the LAN subnets that I've configured. So if I configure multiple LAN links, it will actually get populated here. And then that's pretty much it. Once I do that on the other sites, I have site-to-site VPN up and running across the links I have, across the sites I have. So I'm just doing the same thing with the other sites. Let's go to Man United. So here I have two which the one that we use for client VPN, I can say, yeah, I want to advertise that through. So if I have someone connected through client VPN, I get them access to the full network. And then Milan here is the last one. Remember, Milan was in a pass-through mode. So what I can do, I can enable this, but if I want to advertise specific LAN subnet to say this is my local LAN, I need to specify this LAN subnet here. So now I should actually be able to go to any of the sites and test out if I actually have my site-to-site VPN working or not. So I have here VPN status page. Now it's added to the list. If I click on it, it will start to kind of like tell me, we'll give it a second because it will take some time to establish the tunnels. Not too much, but just like to get some useful information. So you can see from here, it tells me it's connected to Arsenal. So this is from UV. It's connected to Arsenal, Man United, and Milan. And this is the latency, and this is, the left heartbeat. So it's actually connected, and I can see the subnets that are being advertised from there. So I guess it's really important to test the connectivity. So if I go here from Juventus, maybe I would just try to ping an Arsenal. So from Juventus here, let's try to ping this LAN subnet, this IP address, which is 172.16.55.254, which is the LAN subnet here. So this is basically the LAN subnet or the gateway of this VLAN that we have in the remote site in Arsenal. So I can see here it's 2 milliseconds and it's working. Okay, so I managed to ping from this gateway to this LAN subnet here over the tunnel that we've created between the two sites. We're using site-to-site VPN. So how about if I try to do the same thing from Milan, or I want to check the routing table in Milan here. So let's go to Milan and look into the routing table. Can we actually see all the IPs that we advertise? Yeah, so I can see from here there is an IP.77. I can see here the client VPN I have, and I can see that one here as well. So I do have one subnet that not going through, so I'll need to check if there's any rule that could be blocking this from being happening, or give it a second, maybe it will change from red to green. So but you get the idea. So I can actually establish tunnel now over the links I have. I can see that I'm receiving routes from the site that I have here over the internet. So I'm receiving routes from here, and this route, this tunnel for some reason is not working, that we can troubleshoot. But we have full connectivity now. We actually see full connectivity over my network. And this is site-to-site VPN. You can see now it didn't take us more than 1 minute to actually build it on 5 sites. We didn't need to have public IPs. We're using private IPs. We didn't need to have any routing protocols to advertise that through the tunnels. It's actually all done for us automatically. Now, I want to cover another piece, which it's about how to connect the sites over MPLS and how to connect them over an internet. So over internet, it's clear, you need to have secure tunnels over internet. So you connect it up and then to the WAN interface, and then you establish site-to-site VPN to be able to make the sites talk to each other securely. So that's something that you do with the internet links. But how about MPLS? MPLS, we have 2 options, I guess. One is to use the site-to-site VPN, and the other is to connect it to the LAN. We'll cover the differences in a sec, like what are the differences between the two. So if I look into connecting the sites over MPLS and use site-to-site VPN. So I mentioned that if the order of operation that we talked about with the MX, if I have a route, let's say I do have 172.16.155.5, which is my radio server that is basically directly connected to the MPLS. So it's kind of like a route that got injected to the MPLS. So if I connect my WAN connection to the MPLS, then following the order of operation that we talked about, so the MX will look into the routing table when we try to go to this subnet. So the first thing the MX will ask about, is it directly connected? Answer is no. Okay, let's look into the next. Is it part of the client VPN? No, client VPN is the different subnet, or it's not enabled. Okay, and then we start to look at static routes. Do I have any static routes pointing to this subnet? No. Okay, next stop will be Site-to-Site VPN. So from Site-to-Site VPN, do I have a connection going from here to here? Like if I have MX in front of this device and basically have Site-to-Site VPN, then the route will go through because it will be advertised through Site-to-Site VPN. But in this case, no, I don't. Okay, next stop. Do we have a non-Meraki VPN peer that advertising this subnet? Answer is no. Then what we're going to do, we're going to net the traffic and push it over. So what's going to happen here is when we actually go from that client to that client, the traffic will go to the MX, get netted, so we'll take the WAN IP address of the MX and then get routed over to the MPLS. Destination IP will never change, but the source IP will change here because it gets netted. So when the traffic flow this way, it will hit the Active Directory and then it will come back pointing to this WAN interface of the MX, and then the net rule that we have there will basically get the traffic to the private IP address that we have here behind and push the traffic through. So theoretically, if you actually have your WAN subnets routed here through the MPLS, then you can reach out from these sources to these destinations with no problem. But I guess the problem here would be when that subnet is trying to erosionate or initiate the traffic to this subnet, it doesn't know that exists, right? Because it's actually here. We'll go to the MPLS. MPLS will say my destination is 172.16.55. Unless I have a static route pointing this way, it will not know that this subnet exists. So the traffic will be like, unless it's originated from here to the destination, it will work. Otherwise, you will need to do some static routes. So how to solve this problem? There's two options. First option is, as you can see from here, I can connect to the LAN interface of the MX and have a static route saying, okay, you want to go to 172.16.155.5, go to the LAN interface, and done. When I do this, I actually have my traffic going this way, and then I don't need to do any netting or anything. So when the traffic comes back, it will come back to this LAN interface, because LAN interface will not do any netting. If I want to actually do it on the WAN interface, then what I need to do, maybe I'll need to do something like double netting. And double netting means on the MX here, I will actually say, when I go out from this LAN subnet, I want to use the same IP address to go to the WAN interface, not taking the WAN IP address of the MX. So in other words, I will say here to go outside using the source IP to be 172.16.55. That one was 1, to actually get netted to the same IP address when it leaves the MX. So let's try to build this up. So it's pretty easy. So if I go here to my MX, so that one here is Arsenal. If I go to the firewall rules, I can start to do netting there. So here I have something called one-to-one netting. So what I can do here is say, this is my host AIP. The public IP that I want to leave with when I leave the MX will be the same IP as my LAN. So it's kind of like identifying itself as same when it leaves the MX. So what we're doing here, we're kind of like tricking the MX. We're telling the MX, please do not translate to the WAN IP address of this one, use the same IP address when it leaves. So when it hits the MPLS cloud, we know that this traffic is actually going to this destination. And same thing, when we actually receive this traffic distant to this IP, we know that we have a net rule to say, yep, we're going to actually net it back to whatever IP that we have here. So let me do some testing here. So if I go to my host A, which is the one connected at the back of my arsenal, and let's try to do remote desktop to my this is my server here. So this is my Active Directory server. Let's try to do remote desktop to see if the traffic will flow over or not. So straight away, it actually prompts me with putting my username and password. So if I here put my password, boom, straight away, I'm actually inside my Active Directory. So this is my Active Directory that I have there. That I access it from host A. So again, what we've done here, we've said we're doing double netting. So when we actually leave the MX, we'll get the same IP address of my LAN IP. So when it hits the cloud, it will actually use the source IP to be this. Destination IP is your destination. So when the traffic comes back, it will come back to the LAN IP address, not the WAN IP address of the MX. That's one trick. But the downside of this is that if you do have 100 machines here, you need to have 100 net rules on your MX to be able to do the double netting. So the other option is to build site-to-site VPN and do some route leakage, right? So from here you can see MX1, it does actually have connection back to my MPLS. So what I can do, I can actually leak the traffic through to make sure that I get some I get these routes advertised through my Juventus MXs. Let's kind of like try to build this out quickly here. So from the MX that I have here in Juventus, I do have a connection coming back to the MPLS. So what I can do, I can go to my Juventus here. Just want to make sure that I have the link connected up correctly. I go to addressing and VLAN. So first of all, I want to check which ports are connected and which are not. Okay, so I have port number 3 and port number 4. If I go here to my addressing and VLAN, I'll go to port number 4. First of all, I need to add a static this will be MPLS. So the subnet here, the IP that I need to configure, 10.20.0/24. The MX IP in this instance will be output 200. This VLAN I have is 555. Not sure if you've noticed or not, but here when we enabled the SitetoSite VPN, it actually started to ask me, do you want to advertise this route in the VPN? I would say no, because this is the WAN IP. I'm not really interested to advertise it through. And I will just configure this one as an access and have this VLAN, because this is the port that going to the MPLS. Okay, so we've created this port now. What I want to do is I want to tell everyone in SitetoSite VPN I have access to the AD server. So from here, I want to tell everyone in the SitetoSite VPN network, if you want to reach out to this server, come to me, and then I will get this traffic routed through my LAN interface. So first, I need to do this influence, and second, I want to advertise it. So to do this, we said the order of operation will be, if I have a static route, that will take precedence over SitetoSite VPN route. So let's have a static route pointing to this subnet to go through my LAN interface. So to do this, I will have a static route here, and I will say this is to AD/radius, subnet, it's 172.16.155. I will just only advertise this subnet. Next hop IP will be my MPLS, which is 10.10.20.254. Here it asks me, do you want to put this in the SitetoSite VPN? Yes, I want. And then I hit save. So what we've done here, oops, I shouldn't put dash or hash, okay, sorry. Great. So what we've done now, we actually did some route leakage. So we had a connection coming from the LAN going directly to the MPLS. Now I put some static routes saying if I want to reach out to this subnet, this is the way to go. And then I advertise this into the VPN, which basically telling everyone in my SitetoSite VPN network, you can get to this subnet if you want to. So let me go to one of the other sites, let's say Man United, and I want to check the routing table to see if I actually see the static route that we pointed there. So fair enough, here is the route and it's active. So here it tells me, yep, if I want to actually reach from Man United to the AD server that I have on the MPLS, I can actually go to Juventus, and then from Juventus, it will actually send this traffic through. And this is how it works. So from Man United, I received over SitetoSite VPN this static route, and then basically whenever I actually want to push traffic to the radio server, I will go from here all the way to here and then back to the MPLS. And that's how it works. So this is how you can actually do MPLS internet together. So as I mentioned, if you want to do load balancing, then you will need to connect the links to the WAN interfaces. You can't do the LAN interface and do load balancing. Of course, we will create tunnels over both links. So if you do have one kind of like couple of sites or certain sites still not connected to the MPLS through Meraki, then what you can do, you can have one of the sites to act as a gateway and do some route leakage like what we've done now. I guess the next step or the next important thing to talk about here is quality of service, like how to enable quality of service on the network. Because I think, over internet is not a big deal because, it's a best effort. But if you do have MPLS, potentially you actually use the MPLS to prioritize certain traffic over the others. So quality of service is crucial here. So the way it works for us, quality of service is pretty simple. I go here to traffic shaping rules, and then I define, basically I can mark the traffic. So I go here and say, so what we've done in this rule in the previous module, we just said, this kind of like any online backup traffic, I want to limit the bandwidth to, but also I'm giving it a low priority and I mark it as DSCP to be 0. Meaning, when I actually have a congestion at the MX layer, this will be the lowest priority I have. So when I have congestion, I will put this traffic the least. And then I will mark it with DSCP 0. So when it leaves me, it actually will be marked or tagged as DSCP 0. What does it mean for the upstream network? They will get the marking. So I guess a lot of people, and I got this a lot in terms of, people asking, oh, if you do actually encryption, when you do the marking will be encrypted, so the packet will be encrypted, which is true. Yes, the packet will be encrypted, but also what we do, we actually mark the traffic inside the packet or inside the encryption and outside the packets as well. So we put in the header the tagging of these packets. So when it actually hits the MPLS, they will not be able to understand the traffic that we're sending because it's encrypted, but at the header, we put the tagging. So whenever actually the traffic hits the MPLS, it will be hitting the MPLS with a tag. And whenever actually they get decrypted on the other end will be able to see the tag because it's inside the encrypted data anyway. So from here you can add as many rules as you like. So you can go and say, maybe for my voice IP and video, anything related to this, to get unlimited bandwidth, so ignore the bandwidth per client, and set it as a high priority and put the DSCP settings maybe to be EF, right, 46. So that means the MX will prioritize anything related to voice and video, and set the tagging to be EF, so whenever it gets to the MPLS, it will actually get to this high priority. So that's how it works from a quality of service perspective. So in this session we covered, or module, we covered a lot of ground here. So we talked about how to use the MX as a gateway. It's kind of like an introduction to the MX as a gateway. We talked about how to connect up the MX to an MPLS, an internet service. What are the difference between having the MPLS connected to the WAN and to connected to the LAN, how to do route leakage, and then we talked about quality of service. In the next module we're going to cover the dynamic routing, how you can actually use OSPF and BGP on the MXs, and how we can test it out. So stay tuned for the next session.